Hello, ladies and gentlemen. So I'm going to start talking about the seafloor features for you guys. So I'm going to make this full screen here, slideshow, play it from the beginning. Maybe. All right, there we go. All right, so in this unit, we're going to start talking about the seafloor and kind of its different features and what's going on there. So just to get started, the ocean topography is going to be a lot of different things laid out there. So if you look down here at our image, you'll notice so many different main features of it. The continent, continental shelf, the slope, submarine canyon, continental rise, the mid-ocean ridge, sea level, abyssal plain, abyssal hill, island arc, trench, seamount, magma, continental margin, so on, volcano island, or volcanic island rather. So there are a lot of different aspects in the sea floor that you might not be aware of. So basically just getting into the definition first, ocean topography is the study of the ocean floor and the features of which it is. So just looking at what it is, what makes up the ocean floor, and kind of going about that. So kind of a cross section. So a cross section is just literally just cutting it across and taking a look at it from that way. So around 200 meters, we have our continental shelf here, and some of our volcanic islands kind of get to that tip there, the sea surface area. Below that, from 2,000 to 3,000 meters, we're going to have our continental slope. Below that would be the continental rise, and then below that is our abyssal plain from our 4,000 to 6,000. As we go down further, we get into that oceanic trenches, which we're going to talk about those a little bit later. I'm sure you've heard of a couple trenches in the ocean that are extremely deep. Again, they can go up to 10,000 meters, kind of if not more. So our submarine ridge is also over here, and then we already talked about our volcanic island. So notice on the sea surface, we're really only getting that continental shelf and that volcanic island. So the zone of shallow water, where the water covers the edge of a continent, is the continental shelf. So that's going to be this starting spot right here. It has a gentle slope in the average depth of about 200 feet. In the continental slope, we have that descending slope which connects the sea floor to the continental shelf and is still considered to be part of the continent. So it's still in that continent of which it's attached to. It's a very steep slope. The depth increases several thousands feet over a few miles. So again, that is very rapid. Turbidity currents carry sediment further out, and then that forms that continental rise, which you can see here. Which takes us into the continental rise, which is a gentle slope with a generally smooth surface built up by the turbidity currents and then located between the continental slope and the abyssal plain. So you can notice that continental rise down here. It's kind of covered up with this. I don't know if you can see that. Covered up down here, we can see a submarine canyon in this diagram as well. And then we have our continental slope. Again, notice how rapid of a change that slope is. And then that shelf, which again is still kind of shallow at our shoreline. So our deep ocean basins. Now, the vast deep water area beyond the continental slope is going to be these deep ocean basins. And they contain many different features, which are larger than the same features on land. For instance, these abyssal plains here. Abyssal plains are flat or very gently sloped areas of the deep ocean basin floor. Generally lie between the foot and the continental rise of the mid-oceanic ridge, and then they cover about half of the ocean floor. So they are very, very much of the ocean floor, I should say. And again, this abyssal plain is right down here, right below our continental rise, and it takes place all in this area from that 4,000 to 6,000 meter range. Those abyssal hills, hills along the ocean floor ranging in height and diameter. These hills are very much larger than the hills we see on land. So from 100 to 2,000 meters high and several kilometers across. So again, very big. If you guys want to take some time, look up some of the hills that we have and kind of compare those sizes if you want. We can also have the seamount. A seamount is a mountain rising from the ocean seafloor that does not reach to the water surface or to that sea level. It is not an island. Again, it doesn't reach that surface. And they're typically formed from extinct volcanoes that rise abruptly. As volcanoes move away from the hotspot water, or from the hotspot, the water erodes and then they sink below the surface. Now, a Guyot is also known as a table mount, and this is going to be a flat-topped seamount. Okay, so you can see that right here. The flatness is due to the erosion by the waves, the winds, and the atmospheric processes. So again, Guyot is just going to be that flat-topped one. And we can see the progressive order kind of forming it as it goes across from right to left. And again, here's just comparing the two. We can see how they're formed and kind of what's going on here. So you guys can take a look at this if you want. Again, keep in mind, age of the oceanic floor, millions of years present, so it does take a long time. It's not like it's a overnight or a couple month type of thing. We also have our mid-ocean ridge. Mid-ocean ridge is an underwater mounting range, and then it has a valley known as the rift running along its spine and then formed by the plate tectonics. So those of you who were with my other class or earlier previous this semester when we talked about the plate tectonics, you can kind of see where this correlation is and kind of tying it in from being on Earth and on land. On Earth, being on land and being in the ocean. So there's usually an oceanic spreading center, which is responsible for the seafloor spreading, which we're going to talk about in a little bit, the divergent plate boundary. Remember how we talked about our divergent and our convergent plate tectonics? That magma escapes and it's going to form that new ocean floor for us. Now, our divergent plate boundaries. Again, divergent, they're moving apart. So they pull away from each other. New crust is formed. Mid-ocean ridges are also going to be formed here. So we have our two plates moving in opposite directions, pulling apart, and they're going to form this spreading ridge. And we also have this, here's our crust, lithosphere, asthenosphere, and then that transformed fault. So Mid-Atlantic Ridge, we have the longest mountain range in the world along that Mid-Atlantic Ridge, over 10,000 miles long. Peaks of the range are islands. We have Bermuda and Iceland. And now where are ocean ridges? You can kind of see them all along here, all along this solid line that goes through. Excuse me. Trenches are going to be our long, narrow depressions. Now 11,000 meters and deeper that they can be. The deepest places on Earth are going to be these trenches, which again, remember previously how I said you probably heard of some trenches because of this aspect of them being the deepest places on Earth. They have extreme pressures and darkness. Obviously, not any light is going to be able to travel through all the water and get down that far. And then as you keep going, those pressures are going to get heavier and heavier the deeper you go into that ocean. So again, if they're the deepest places on Earth, it's going to have very high pressures. And those are going to form near the subduction zones, and there's unknown life. We don't really know what's going on down there. If you ask me, it's probably some sea monster just waiting to get out and come, attack us, Godzilla type thing. Megalodon, maybe. Deep sea trenches. The Marianas Trench is going to be 36,201 feet deep, 6.8 miles. It's also going to be about 1,500 miles long, 43 miles wide. Pressure's 8 tons per square inch. You don't want to have to deal with that sort of pressure. Now, getting into hotspots a little bit. So, caused by the mantle plumes, direct link to the core mantle boundary, and then the upwelling of magma forms a volcanic island, such as Hawaii. As plates move, island chains form. So you can kind of see what's going on here, forces the cause of the plate tectonics. So we have our mantle, we have these pressures and the heat coming up. Those forces, the slab pull is going to pull it down here, forming our trench, and then the ridge gets formed as well. So here you can see the hot spots going through, direction of the plate motions going, forming these smaller other islands as it goes. Hawaii obviously being here, and then Maui, and I don't know how to say the other islands, so I'm just going to keep going. Location of hotspots, we have a bunch of hotspots. Notice Yellowstone here, the hotspot. Then we have our Hawaii, Galapagos, Iceland, and so on and so forth, and then a bunch of these other ones that kind of go through. So, other ocean features. Atoll is going to be a circular shaped coral reef that surrounds a sinking volcano. As the volcano sinks, a central lagoon is formed. So you can kind of see what's going on here. We have our comparisons. Our atoll is going to be here with our lagoon. We have our Guyot right here again, and then our sinking island with our barrier reef again as it's going through. So in the formation, we have our fringing reef, our barrier reef, and then our atoll. And you can kind of see the differences in this image here. Here is an example. And then there's an example. And that concludes everything. So I just want to thank you guys for watching. I hope you enjoyed.